This aluminum control panel that I made for the electronic lead screw sure looks great with the engraving and the paint inlay, but there are a lot of hours involved in producing one of these. So today I'm going to make a new one that uses a silk-screened PC board as the front panel. It should still look great and be much easier to produce in volume. Welcome back to Cloud 42. I'm James. I will apologize in advance if you hear background noise in this video, particularly children screaming. All the kids in my neighborhood have been off school for about a week now due to the global pandemic that we're all facing, and they, quite frankly, don't know what to do with themselves. But that is a minor inconvenience compared to what a lot of other people in the world are dealing with. So far where I live, we've got a small handful of cases. There doesn't appear to be a lot of community spread yet, but that could change any day. So we are all taking precautions. We're all working from home. And so far, all of my friends and family have managed to stay healthy, and we hope it will stay that way. For the people in the world who have not been so fortunate, our thoughts and prayers go out to all of you. This is the control panel, of course, that I made for the electronic lead screw, and I've had a lot of people contact me and ask if they can buy this. And the answer is, I can't really afford to do that. There's so much labor involved here. Because of the speed of my mill spindle, it takes a while. It's a long cycle time to actually mill all of this out. I showed that in a previous video. And the engraving takes even longer. I did try an experiment with using a diamond drag engraver, which would be much faster, and it ended up just being kind of illegible. And so I went ahead and just engraved over the top of that to depth and made another one, just trying to see how fast I could do it. But it's just, it's time prohibitive to manufacture these in any kind of quantity. So what I want to do today is I want to design a new control panel, or a new front panel that is exactly like this and is interchangeable and will drop in, but that is made as a PC board with the markings done with the silk screen. That's something that could still look great and could be manufactured in any quantity just by placing an order to the fab. So let's go into the computer and work up a PC board design for a control panel. I'm going to design the PC board control panel in Fusion 360. As you know, Autodesk a couple of years ago acquired CADsoft, and they have been integrating the Eagle PC board design software into Fusion 360. This will be the first PC board that I've actually designed with this tool, so I am by no means an expert, but we'll go through the process. I spent a bunch of time figuring this out, and maybe you'll learn something, and maybe you'll teach me something. If you see something that I'm doing wrong or there's a better way to do it, throw it down in the comments, and we'll all learn something. This is the 3D model for the control panel, and you can see here I've got the bud box around this, but we can take the box off the back, and I have everything modeled here, the connector, which I'll get out of the way, the PC board and spacer, and the buttons that all fit into here, and then the sketch for the engraving on the front panel. And we're going to replace all of that, so let me get rid of the sketch. And what we want to do is design a PC board that fits in place of this front panel, but fits into the box. So let's get rid of the front panel for now. And let's get rid of the screws that are in the way here. And so we want to design a PC board that fits into here. Now I'm going to not sketch the PC board outline directly on the surface here. I'm instead going to pull a construction plane forward off of this just so that it's not in the way and we're not dealing with these contact surfaces creating implied edges, and we'll just create a sketch on this surface. Now we need to bring out the outline of where we want the PC board, and so I'm going to turn on construction here because I want to offset from this, and I'm just going to hit P for project, and we're going to go in here and click around the inside edges of this box where we want the edge of the PC board. And then I'm also going to click these holes where the screws go so that we can put screw holes in the PC board that line up perfectly. Now I'll say OK, and that'll give us construction lines out here. Now for the actual edge of the PC board, I want to offset from this so that it's not actually in contact. It's a little bit smaller. So hit O for offset, click here, and we'll go in, say, minus 0.2 millimeters. And I don't want that to be a construction line. I want that one to be solid. Okay, and now let's put in some screw holes. So C for circle, and I'm just going to put a circle centered around each one of these. Now I didn't want to use the actual projected hole from the box because it's actually a little bit smaller than the screw diameter so that the screw will thread into it. I want to make a clearance hole. So let me just select, hold down Control and click all of these circles to select them, make them all equal, and let me dimension those up. And my favorite table here says a clearance hole should be 144 thou. So 0.144 inches. Okay, so that gives us the actual outline of the board and where the holes should go. Now we need the openings that we milled in the box cover as holes in the board as well. So I'm going to go ahead and turn the lid of this thing back on, and let me turn the buttons off so they won't be in our way. And let's hit P for project again. And let's grab a few things. The mounting hole, and then I'm catching the inside, the actual inside of the chamfer of these holes. So we'll get a hole in the PC board the same size as the hole that we milled in the aluminum case. Okay, and what does that give us? We've got the outline of the PC board, we've got all the holes for the screws and the buttons and the lights and the window here. So that is our sketch, and that is the outline that we'll use for the PC board. Okay, to actually create the PC board, we come in here and say Create, and at the very bottom there's a new option here, Create 3D PCB. I'll select that, and then they want a profile. I'll select that profile and click OK. And now it has created a 3D PC board model. And this has layers for copper and solder mask and any 3D packages for components that will ultimately get mounted on it. Let me just save this. Okay, control panel PCB 3D. There end up being a whole bunch of files once we do this. So we've got the outline of the PC board. That's the 3D PC board. Now we need to create an electronics project that's going to contain the schematic and the 2D PC board that will be linked to this. So we can come up here and under File and say New Electronics Design. So this creates a new electronics design, and let's create a new schematic. The electronics design starts from a schematic where you put in components, then those get linked to a 2D PC board design, and then you link the 2D PC board to the 3D PC board, and it then synchronizes the shape of the board and the components back and forth as you make adjustments. So let's add some things to this schematic. Now, ultimately, I'm not putting any components on the board, but I do want this to be shielded. So I do want to put copper on the front and back of the board, and I want to have those connected by plated through holes on the screw hole so that the screws will connect it to the grounded box. So in terms of I couldn't figure out how to put a pad down or a through hole, a plated through hole. So what I did is I created a library and made a component that just has a plated through hole pad. And so I'm not going to go into that here, but this is a plated screw hole that I created for a number 6 screw. So I'll just say OK, and I'm going to have 4 of these on the 4 corners, so I'll just lay those into the schematic. And then I also want to place a ground symbol, and I want an earth ground symbol. Place that here, and then we'll just route and connect all of these screw holes to the ground. And that is our schematic. And let me go ahead and save this. And this was the electronics project that has that link to it. Let me go ahead and save that as well. Okay, so now I've got this. Let me add a 2D PC board. So I'll click New PCB, and it will add this. And this is now a PC board that's connected to the schematic. We'll save that as well. And you'll note the outline of the board is just a basic rectangle, and we have our components down here. We have the 3 screws sitting over here off of the side of the board. So I'm going to go back to the 3D PC board and click Link to 2D PC board up here in the corner. So I click on that, I select my 2D PC board design, and it links them together. So now we're back looking at the 2D PC board, and you can see that now it actually has the correct shape with the correct openings in it. And before I go any further, I'm going to go ahead and save this. But in order to complete the linkage, if I just try to save this right now, it'll warn me that the 2D and 3D PC board documents are out of sync. I don't know why that is, but if I just click up here, say View 3D PCB, it'll take this 2D design, push it over to the 3D model, and now I can save everything and it's all linked together. You can see we've got the green solder mask, we've got the holes over here on the side, and it's trying to show packages. I didn't define packages for these, so I'll just turn off that layer because there's nothing there. So we have our 4 plated screw holes that are going to go in these corners, and we've got the PC board. And now we can just save everything. In fact, when you save the 3D PC board, it saves everything except the electronics design. I will admit, I honestly don't know how these things are connected. It seems like kind of a mess to me. Okay, the first thing I want to do is take these holes that were defined in the sketch, and I want to replace those with the plated through screw holes. And I couldn't find a good way to do this except just to mess with the coordinate system. So I'll click on this hole and I can see the location. 115, 115.20079. I have no idea why that fraction, but I am just going to go ahead and hit Control C to copy that. So now I can get rid of this hole by highlighting it and hitting delete. And then I can click on this hole and just change the location. 115 dot paste, 115 dot paste. And so now I have that screw hole in the location where the hole in the PC board had been previously. Let me just go ahead and put the rest of these in place. Okay, so I've got all those screw holes in the right locations in the corners, and you'll see that there's an error being shown here, and that's because the copper of that screw hole is too close to the edge of the board, given the design rules. So I'll just go over here to the Rules DRC ERC tab and click on the DRC, which is Design Rule Check, and it will pop up the rules. And I can go over here to, let's see, clearance, that same signals, distance, copper to dimension. So the distance between copper and the outside dimension of the board is set to 40 mils. I'm going to set that to 5 mils. Apply and then check my rules, and I have 3 failures, and those are air wires because these are all marked as being connected to the ground, and they're not actually connected to anything. So that is fine. We will go ahead and take care of that next. So instead of hooking traces between these, I just want to have these connected to copper fills on the board. So we'll go back over here to Design, and we'll go over here to the Pour section and define some polygons. The first one is on the top layer, and I will just click. I'm just creating a polygon that is bigger than the board because it doesn't really matter, because it'll only put copper where the board is. And this will be the same as the signal that we have here on the screws, which is EGND, E ground, the earth ground. Okay, and so that defines that on the top layer. Now I'm going to put one on the bottom layer as well. Click, and this will also be E ground. Okay, so now we have the polygons defined, but no fill. So we'll just go up here and click Pour Polygons, and it will pour it. So if we look at the top of the board, you can see we've got a pad here with copper poured all around it. And if we look at the bottom of the board, we see exactly the same thing, blue with the copper poured around it. We can go over here to manufacturing, and we can click on Cam Preview, and it will open up a preview of what this board is going to look like. So we're looking at the top, the green solder mask, and we can look at the bottom side, and it looks basically the same. Let's change a couple things here. We're actually going to make the solder mask black, and we're going to make the silk screen. That's going to be white, and let's set the copper color to, I don't know, something silvery. Okay, so that's what the board's actually going to look like. You can kind of just barely see it. So that looks okay. Looks like we're getting what we want. Okay, and obviously we need to put some text on here. That's the whole reason we did this. So let's go back to document, which is where this happens, and we're going to put the text in the T names and B names layers. So T names is the top names, B names is the bottom names. So T names, this will go into the top silk screen, and we'll just say draw text. Now we'll enter the text. First thing we want to put on here is the RPM marking. Now we have 3 fonts, and we have vector, proportional, and fixed. And I've messed around with this, and no matter what I do in here, it appears to always output a vector font. If I say proportional and adjust it the way I want, it doesn't come out that way. It sends the vector to the Gerbers anyway. So I don't know. If you know how to deal with this or how to choose other fonts, let me know down in the comments. I don't know how to do it, so I'm just going to move forward with the vector. And let's go ahead and see how big that is. That's not anywhere near big enough. Let's run that up, say 200. Yeah, that looks pretty good. Ratio, go 12%, make it heavier. Okay, we want an RPM there, and then feed over here-ish. And then we need our labels along the top. And that's power, forward, reverse, feed thread, millimeters, inch, TPI. And obviously that's way too big. Let's try something like, that actually looks pretty good. Let me put another space in here. Okay, now obviously I'm not able to place this exactly where I want, so over here on grid, I'm going to change the grid settings. Right now it's 50 mil, I'll make it 5 mil. That will give me a little more freedom in positioning this. Okay, that works for that. I need to label the buttons down below. And these I'll do, some of these are multi-line, so I'll have to do them separately. Power, that'll work for that. Power set, forward, reverse. I want this centered. Okay. Good enough. And let's grab and put a little bit more text on this thing. Right click the mouse to rotate. I actually want it to go the other way, so we'll flip the spin. And that's way too big. Okay, that's good for the front. Now let's look at B names and put some things on the bottom. And our layers, I'll say flipboard, so we can look at the bottom. Okay. And then for, since we're going to have these manufactured at JLC PCB, I don't want them putting their serial number or their order tracking number on the front. I want to control where that goes. And the way you do that is JLC, 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 and you just put this text somewhere on the board. And then when you place the order, you have to let them know that that's there, and they will utilize that. So that's the back. Let's flip it. And look at the front. That looks pretty good. We can pop over here to manufacturing and look at the cam preview. That looks pretty good for the top. That looks pretty good for the bottom. Okay, now let's push this over to the 3D PC board. And that looks more or less like what I expected. So we've got this PC board. Now let's take that and put it back into our 3D design. So here's the 3D model. Let me turn off the sketch that I used here. And let's turn off the front panel of the box because we don't need that anymore. We have our model in the box here. In fact, I'm going to go ahead and turn that box off completely. Now let's take the PC board and line it up here. So let's insert it and just take the 3D PC board, drag it into our model. I'll just stick it someplace where it's not going to cover anything up. And then we'll just join this up. Now this, if I start moving things around, you can see it separates. I'll just hit Control Z to put that back. That's because it did not add a rigid group. I'll just right click and say rigid group. Okay. And now when I grab this and move it, it all stays together. So I'm going to join this, hit J for join, and then I will come up here and grab the back of, let's say, that screw hole, and join that up with the matching screw hole here. And that'll place the PC board in the correct position. And click OK. So now we have that PC board on the front here. And it looks like everything lines up. You can see that my RPM's not perfectly centered here, and feed could move a little bit to the right. And I'm not going to mess around with any of that stuff today. For these purposes, just understand, you'd go back and make adjustments to make this fit. Now I'd like to put a box on this, but if I just turn on this box, you can see that we're in the wrong position. And since I've got the other stuff in this model as well, I'm just going to forget about it. I'm just going to hit Control C on the box and Control V, and I'm just going to insert another one. And we'll just mess around with this second box, which we can move around and put wherever we want. So I will hit J for joint again. Whoops. Okay, hit J for joint, and I'll just say capture position because I moved it out there. And let's line up this screw with the back of the PC board here, and I'm going to try to catch the edge of the copper layer. Okay, so you can see the way that's fitting in there, it is sunk down below the surface of the box. I'd like to have it at the surface or even a little bit proud, especially since the head of the screw is going to overlap the box slightly and I don't want it to bind. So we'll push the box back, say 1 millimeter, and that'll put us just proud of the surface. And I think I like that. I think that will be fine. Now what that means is that on the inside here, turn this box off, it means that I'm going to have some kind of a spacer here to hold this forward. And what I'm going to do is I already have this plastic bridge piece that's in here. I'll just redesign it and add little tabs that come out that are 1 millimeter thick that come out and go around that screw hole, and that'll make it fit neatly in there and create that space. And just to get an idea what this will look like, let's turn the buttons back on. And those should fit exactly the same. And let's put some screws in this thing. So insert McMaster car component, screws. Whoops, I want rounded head screws, hex drive, and these are 632. Let's go with 5/16, and we'll just grab any model in here. They're all going to be the same. And I want a step file. Put it out here where it won't be in the way. Rename that so I can keep track of it later. And then Control C, copy, Control V. So I'll insert 3 more copies of it. So now we've got 4 of those screws. So now I can put those in the correct locations. J for join, grab the underside of the head, grab the front of this hole, and then do the other 3. Okay, and let's do the same thing for the screws that go through the front here. What we had used previously in the model was a flathead M3 screw because it was countersunk, but we don't have countersinks here since it's a PC board, so we'll just go and do some button head screws. Screws, rounded head, metric, M3 by 16. Now the silver screws in here are kind of nice, but I think I would prefer black. So I'm just going to right click here and say appearance. And we're going to go down here to metal, coatings, coating black oxide. And I'm just going to drop that onto that screw. Now in this model, they're showing the appearance of the black oxide being darker than the PC board, but I think in reality it's going to be, they're going to be pretty similar. So that, I am very happy with that. And if we go in here and look at these corners, you can see that that screw head does overlap the box a little bit because it goes past the edge of the PC board. And that's just because in the bud box design, there's a lid that sticks up another 1/8 of an inch or so, another few millimeters, 3 or 4 millimeters. And then the countersink is in that. And so it's not really designed for a screw to go down inside the box. But I think this is a good compromise, and I think it looks pretty sharp. I'm pretty happy with this. So let's export this PC board and get it manufactured. When I have exported PC boards from a circuit maker and uploaded those to JLC PCB, I had to mess around a bunch with the files to actually create what JLC PCB was expecting, but it turns out that in Fusion 360 with the integrated Eagle CAD, it appears to just output files that work with no modifications at all. Now, I haven't done anything with assembly yet, but just for PC board manufacturing, it works pretty well. So we'll go back over here to the 2D PC board model and go to the manufacturing tab. And then there's a button here for CAM export, and we just click CAM export. And it shows in the little pop-up dialog that popped up on my other screen all of the files that are going to be in it. I can just click OK and choose a location. And it chooses this Fusion 360 Electronics CAM and names the file with the name of the project and the actual version and the date. That looks good enough. We'll just grab a browser and go to jlcpcb.com and click the quote button. Add your Gerber file. Here's the file. And that sure looks like what I want. We'll click on the Gerber viewer here and go have a little closer look and make sure this really looks right. The biggest thing I was worried about is the internal cutouts, but boy, that sure looks like it's doing the right thing. And we've got the plated through holes on the sides. Great. And let's see, layers 2, dimensions, you can choose quantity. I want a black solder mask. I definitely want lead free. It's a little more expensive, but if I end up selling these and I ship them to Europe, I want them to be lead free. Don't want them to panel. There's no point in testing these at all because I don't care about the electrical connections. And here's the remove order number. You can say specify a location and it will use that little JLC, 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 JLC that I put on the back side. And that looks like that is about it. I can go ahead and place an order, and in fact, I already did place an order for these. And through the magic of planning ahead, the boards are back from the fab. Pull one of these out, drop it here where you can see it. I am pretty happy with how this turned out. Now you'll note that the lettering is fairly light, it's very, very fine, and it isn't as dark as I would like it to be. And as it turns out, I mentioned when I was showing how to make the PC board that there was an issue with the fonts. I had originally designed this to use the proportional font, which looked much bolder on the screen, but when it output the Gerbers, it switched to the vector font. And I honestly don't know why it does that. If you know why, you can throw that down in the comments. But what I saw in the preview and what actually came out in the CAM, and of course it was in the CAM preview, but I didn't notice, and it was in the preview on the PC Board Fab website, and I didn't notice, but was this finer font. So I actually have a newer design, that's like the one I showed you, that has a slightly larger text and darker text, gone from the default like 8 or 9% to 12% on the thickness. So I have some other ones, and I will be ordering another batch shortly that should look a little bit better than this. But honestly, these look really good. The text is fine, but it's really legible. I'm really happy with what it looks like. And we've got the text on the back. The copyright notice and stuff is all very legible. I'm pretty happy with it. And if you look down here real close, we even have the JLC PCB tracking number down there where I had it, the JLC, 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 JLC text on the board. They've actually replaced that with their number, which is down here on the back, where it is out of the way and will not be visible in the finished product. And looking around the edges, I was worried that you would be able to see where the edges of the copper are, where it's held back from the edges of the board, and honestly, I don't really see any issues here. I think this looks great. So I'm totally happy with that. One of the things about this board, I don't know how well you'll be able to see it. You probably won't be able to see it very well, but it is ever so slightly warped. And the reason for that is because this first version, I only put copper on the back. I did not have copper on the front. Really, there was no reason for that except I was worried about what the copper would look like. So I've changed it now. You saw when I redid it on the computer just a minute ago that I have copper flood on the front and the back of the board, and that should make that a little flatter. Though it really doesn't matter because once this is screwed in place, it's going to be pulled down flat anyway. Speaking of screwing in place, I do have the modified version of the bridge that I talked about. And the purpose of this is it has these extra tabs that come out. So this will just sit in here and those tabs go out to the corner and provide the 1mm space on the top of the mounting studs so that the PC board will sit in there cleanly on top. So I have the PC board here, and of course this bridge goes over it, and then the PC board for the control panel goes on the front. Now you can see that all of those letters are nice and white and visible, so I want to cut out a piece of red filter and put it over the front of that, and then a piece of clear plastic to go over the front of that to then protect it, because the PVC material of the red filter is actually pretty soft. Oh, I need to cover that portion of it. And I've got this set up so that it should be close to the surface here, so I should be able to just put it on. I can see that on this print it is just a shade below, maybe 0.2 of a millimeter, maybe slightly more. And so it's going to warp it a little bit, but it'll be all right for this. Okay, this will end up sticking to the front of that, so I won't go ahead and stick that down just yet. I need to cut a piece of clear plastic to fit over that as well. It's not blood on my finger, it's a little piece of red filter. Okay, so that's now on the back, and we've got the clear window over the red filter. I don't see anything stuck to the filter. We've got our screws in. Let me find my buttons. These are the 3D printed buttons made out of Ninja Flex. Drop those in, and then we're ready for the PC board. And when this goes down, the displays will stick to the adhesive of the filter. Okay, and let's put some nuts on the back. Okay, that is the control panel, and then this should drop right into the box. And it does. It's a little bit tight, and the second order that I'm putting in with the bolder text, I thin this down by about 5 thou, top and bottom. Now these screws, the threads are not great on them because I didn't actually have 5/16 inch screws. The ones I had were a little bit too long. So I shortened them on the bench grinder, and it kind of mangled the last thread, and I cleaned them up the best I could. I will place an order for some proper screws shortly. And that is how it looks fully assembled. I gotta say, I kind of like the black, and it's not a shiny black, it's kind of a matte black. And then couple that with the matte black of the oxide coated screws. I'm really happy. I mean, I like these both. I do like the aluminum with the engraving. That's really nice, but the black looks pretty sharp, and of course, since that PC board is manufactured in a fab and silkscreened, it's much easier to make these in volume. It'll look even better when I get the final PC board with the bolder text on it. And I am thinking about making these available. Leave a comment down below and let me know if that's something you would be interested in. I could make just the PC boards available. I could do a kit with the PC boards and the 3D printed buttons and the 3D printed spacer. Though I have heard some rumors perhaps that the button board underneath comes in some different versions with some slightly different spacing. I would need to investigate that. It would also be possible to put together an entire kit with the bud boxes, with the PC boards and stuff. That would of course take more time to put together and to mark it up so that I could handle it and ship it and actually make it worth my while. The price is going to be a little higher maybe even than you could buy the parts and do it yourself. But let me know down in the comments if this is something you would be interested in and kind of what you would be interested in. And we'll see what we can do. I'll get some more boards ordered with darker text on them, or the brighter, whiter, bolder text on them, and we'll see how that goes. If you're enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.